For more than 4 decades, the most distant human-made explorers have continued speaking to us long after their expected silence. Their signals do not arrive as strong transmissions, but as faint whispers stretched across billions of miles, delayed by hours and weakened by the immense distances they must cross. And yet, against all expectations, they endure. Each fragment of data they send is more than information. It is a connection, a fragile thread linking our small world to a region of space that once existed only in theory. Voyager 1 and Voyager 2 were never designed for this kind of longevity. Built in an era when computing power was primitive by modern standards, when storage was measured in kilobytes and commands were uploaded with astonishing caution, they were expected to survive only a few years. Their purpose seemed simple: visit the giant planets, transmit discoveries, then slowly fade into silence. But space has a way of rewriting plans. Decades later, these machines continue moving beyond the outer planets, beyond the fading influence of the Sun, and into a region where the boundaries of the solar system dissolve into the wider galaxy. That region was once imagined quiet. Empty. A cosmic void. But the farther these spacecraft travel, the stranger that assumption becomes. Recently, one of their transmissions carried something unexpected. For months, engineers had struggled with incoming signals. Structured patterns fragmented. Telemetry became erratic. At times, it seemed the distant voice of the spacecraft was disappearing into interference. After nearly half a century of radiation, freezing cold, and isolation, many feared the end was near. Then, without warning, a coherent signal returned. Faint. Delayed. But unmistakably alive. It had crossed the abyss carrying structured information still decodable on Earth. The spacecraft had not gone silent. It had recovered, still observing, still measuring, still revealing. That moment was more than a technical victory. It was a reminder that even at unimaginable distances, these explorers remain active participants in discovery. And what they are sending now is reshaping our understanding of where the solar system ends. For decades, scientists imagined the outer boundary of the Sun's influence as relatively simple. The solar wind, a stream of charged particles flowing outward from our star, creates a protective bubble called the heliosphere. At its edge lies the heliopause, where solar pressure meets interstellar space. That boundary was once pictured as smooth and stable. Reality appears far stranger. The data suggests it is not a single edge, but a layered frontier, a dynamic boundary zone filled with shifting structures and fluctuating conditions. Plasma densities rise and fall. Magnetic fields twist, distort, and sometimes suddenly realign. Conditions can change over remarkably short distances. This is not a border. It is a collision zone between the Sun's influence and the forces of the galaxy. Before communication stabilized, the spacecraft had already begun detecting anomalies there. Plasma vibrations where none were expected. Magnetic patterns appearing structured rather than chaotic. Cosmic radiation fluctuations hinting at deeper order. At first, some suspected malfunction. Aging sensors. Instrument drift. But repeated analysis suggested something more profound. The signals were real. The outer boundary of our solar system behaves almost like a living structure. Some researchers describe it as a membrane, flexible, responsive, almost breathing. It expands and contracts with the Sun's activity cycle. When solar activity rises, the heliosphere swells outward. When the Sun quiets, it retreats. Meaning the edge of our solar system is not fixed. It moves. It reacts. It changes. Crossing it may be less like passing a line and more like moving through invisible weather systems. That realization changes perspective completely. The solar system is not isolated. It exists embedded within a galactic environment shaped by forces far beyond itself. Ancient supernova explosions, galactic winds, and magnetic currents stretching across light years. Ripples from distant stellar events may reach even here. Some regions appear to shield against cosmic radiation more effectively. Others seem porous, allowing energetic particles deeper inward. Then came another mystery: abrupt magnetic reversals. Sudden directional shifts too rapid for slow processes alone. Scientists suspect magnetic reconnection, a phenomenon where magnetic field lines break and reconnect, releasing bursts of energy. Known near the Sun, but now observed at the edge of interstellar space on immense scales. Plasma oscillations followed, wave-like disturbances moving through ionized gas, showing the boundary itself can carry energy like vibrations along a stretched cosmic surface. All pointing toward one conclusion: interstellar space is not empty. They are emissaries. Witnesses. Proof that curiosity can travel farther than anyone imagined. One day their power will fade. The final signal will come. Then silence. But their journey will continue for millions of years, carrying the memory of a species that dared to reach beyond its star. And maybe that is their deepest lesson. The universe is not a fixed place waiting to be mapped. It is layered, restless, revealing itself only to those willing to cross boundaries.